Hello class, my name is Shunonita Sharkar and I'm your MECH 488 instructor. Today is our first class. So before getting to the course material, I want to discuss about our syllabus and the schedule and how we are going to meet in this class. So last time I checked, there's still 10 or 12 students who have not answered the survey that if they want to attend the class in person or remotely. If by the end of this week I don't get response from them, I will assume that they will attend the class in person, and that's how I will set up a group. As I mentioned before in the syllabus, that the maximum amount of people who can attend class in person is 29 or 28. So we won't be able to accommodate everybody. So every other week, one group of students will attend the class while the other can either join via Zoom, like synchronously, or they can watch the lesson in a different time, because I will upload the class after each session. And all the lab sessions will be in person. So the department has not finalized a TA yet. So once we get that sorted out, he or she will contact you and will discuss about how they want to conduct the lab session. So this is more like a hands-on class. So the main thing is there's like no exams. So everything that matters in this course is that what you are doing in the lab and how you are presenting that in the lab reports. So, and the lab reports will be graded by the TA and also by me. So be very careful of like attending the lab and be very careful with the reports, because that's how you're going to be graded in this course. So let me share the syllabus with you. Give me 1 second. Okay. So here is our tentative schedule, and as this week it's all remote, but we have 6 projects, or not all are as time intensive as, like not all of them are same. So some would require more time, others is pretty much easy. So I would suggest you guys to plan accordingly. Like the lab 4, that's like the biggest one. So you have to design a project and you have to build a prototype. So you have to and part of the design is actually thinking about your resource and how you are going to use that to the fullest, such as in this class. Previously what student has done, like they designed a part and they 3D printed that part using the department 3D printer, and they all wait for the very end. So if 7 or 8 groups all trying to print on the same week, so definitely some of you will not be able to print on time. And as I said, it's totally lab report dependent. Your grades totally depends on your lab reports and how you finish each project. So if you cannot finish it because of poorly time management, then that's gonna affect on your grade. What else? So depending on how the semester goes and if there's any changes on the guidelines, we might have to reduce the labs, or otherwise we will try our best to do all 6 of them. But if any changes happens, then we will try to let you know as soon as we can. And let me see. I think that's all. I have this syllabus uploaded. If you guys have any questions, you can email me. It's pretty straightforward. Yeah, so videos will be uploaded, so you can either attend via the link that I have here, or you can look up the Canvas website probably the next day or the evening of the class, and I will have the lectures uploaded. So that's all about the syllabus. So let's move on to our first class. So the first, on your first lab, the experiment I have for you is, it's titled like adjustment calculus. And this is, this is a pretty interesting topic. So it's not like the calculus that we have learned so far. It's pretty basic, basic math. So what is adjustment calculus? So it's a tool, it's a powerful tool that we use to estimate like velocity and acceleration of a mechanism. So for example, let's say you have a robotic vision system or a computer vision that is tracking a fast moving object, let's say like a bird. It's tracking a bird and it is planning to capture, like this robot is planning to capture this bird. So what it's going to do, based on its current trajectory, it will predict where the bird's gonna be at certain time. So it will predict its displacement, its velocity, and its acceleration. And based on those calculation, the robot will estimate that where its gripper or the capturing device needs to be and at what time. So this is how how this calculation the computer is doing, that is in a simplest way we can do is by using adjustment calculus. Another, this is quite a complicated example, but I just wanted to give kind of like a both extremes, like a very complicated one and also like a very simple one, and something that we are already very familiar with, that is like a cam mechanism. So in your and kinematics and machine design, no, that's dynamics and kinematics class, the 432, I believe. So you, in that class, you learn how to design a cam profile based on the follower displacement. So if you need if you need a primer on like cam design and just about the different terminology of a cam, then you are more than welcome to send me an email. I will upload like a short video on just a cam profile and cam design, but it's not very much required, and since the course was already a prerequisite, so I'm assuming that you are very familiar with the cam and the different terminologies of the cam and how to design a cam. So I'm not going over the details, but if you need, just send me an email or give me a feedback, then I can upload a short video about cam design and different parts of the cam. Okay, back to our current problem, which is, so you design a cam profile based on the displacement of the follower, and then you produce that cam. So you do machining, you do like surface polishing and all that, and you have this cam ready to put into your equipment. But before you can do that, you need to make sure that your theoretical analysis and the cam that has been produced by the fabrication team, those are same. But sometimes due to different machining or measurement issues, the theoretical design and what you have in your hand can have like hundreds of percent of error. And due to those errors, when you put your cam in your machine, it will not work the way you wanted it. So So what can we do? So we have to inspect the cam before you can put in a probably like a very expensive machine. You have to make sure that it is in the tolerance, like the acceleration of the follower is within the tolerance. So you have to inspect this cam before you can use this. And how we do this inspection. So this is kind of like a reverse engineering. So you did your theoretical analysis before you actually produce this cam. So you have your different motion theories, like formulas that you use to design this cam, and you have your graphs of the motion of this follower. So you have your displacement graph, you have the velocity, you have the acceleration, and the jerk. And if you remember from your previous course, then you know that the basic rule of cam designing is that all of this velocity, acceleration, jerk, and also displacement, of course, needs to be a constant, and not a constant, but it needs to be continuous. So otherwise your cam follower would have a jerky motion, so that could introduce like way more error in your application. So you want this smooth curve for all of these motion parameters. You don't want any sudden rise or any sudden fall in your cam profile. So what we are going to do now, what we are going to do in the inspection is that you have your cam. So before putting this cam into your machine, you will put into an inspection setup, and you will inspect those curves. So you will reverse engineer those curves from the device you have, and you will compare your theoretical data and your analytical data to see that what is the tolerance. Is it in a tolerant limit, or it's not? Is it like, do you have to reject it, or you can go with this? And to do that, here comes the part where we need adjusted calculus, because how are we going to measure velocity or acceleration or jerk? So there's many ways. You can attach like a speedometer maybe, or you can have like nowadays for inspection, a lot of industries, they do that. They have like visual inspection. So they have computer like camera and algorithm and image analysis, and that's how they do the whole math, just to like rotate the cam, and by image analysis they figured out the velocity and acceleration. But here in this class we are kind of going back in the time to understand the basic of it. So we are going to calculate everything like by hand, and how so that you know that what's going on those high class software or machines that calculate those terms for you. So you will rotate this cam 360 degree with known interval, let's say 5 degree, and each 5 degree you will measure the displacement. And so you have a full rotation, and you have displacement for every 5 degrees. And once you have those displacement, using adjusted calculus, you can derive velocity, then acceleration, and then jerk, because velocity is just first derivative of displacement, second derivative of displacement is acceleration, and third is jerk. So so this is a numerical method that we are going to use to calculate our velocity and acceleration, and this is called method of finite difference. So some of you might be familiar with this process. This is very simpler, but there are some pros and cons. Pros are definitely that this is a very simple process, and you can, with minimum calculation, you can get your velocity and acceleration data. So what's happening here? So this is a 1D or one direction example. So let's see, your object is, this is your reference point, and your object is moving in X direction, and this is like all those round points are the displacement at different times. So the distance between 2 points are different, but the time spent while the point went from point A to point B, the time is same. So here, let's assume that we are interested in I term. For some reason, we are always interested in the I term. So this is I minus 1, and this is your I plus 1. So these are same, time difference is same, distance is not. So how you measure the velocity of these two times? So you subtract xi minus xi minus 1, different time, and similarly xi plus 1 minus xi, difference time. So basically you are taking the average velocity of this 2 point, of this 2 distance, and that is your average velocity at this point. So you are taking the velocity of the point before and the point after, taking the average, and that's how you get the velocity of the point I. Similar for acceleration, but instead of subtracting the displacement, you are subtracting the velocities at I plus 1 and I minus 1. So here, this is the velocity at this point, I plus 1 point. This is the velocity at I minus 1 point, and you are subtracting that and dividing by the time, because now we are taking acceleration, so it would be delta t square. So you have your formula for velocity and acceleration. So using this formula, you can calculate the velocity and acceleration. So let's do a simple example so we can calculate that. So this is our example where we have this, so we have a full circle of 36 degree, and we have displacement at every 5 degree. So we need the first difference, and then we need the second difference. So, let me go back so that I can write on it.